Hey guys, welcome to video 3 of week 2 with part 2 of your lesson on the unit circle and reference angles. So we're going back to reference angles. Get out your TI-84 and for a moment here just plug in these 6 trig ratios and find the sine and cosine of 60 degrees, 120 degrees, and 240 degrees. Okay, so yesterday, or in the previous video, you already found that sine of 60 degrees is 0.866, sine of 120 degrees is 0.866, and sine of 240 degrees is negative 0.866. And then if we do the cosine of 60, it's 0.5, cosine of 120 degrees is negative 0.5, and cosine of 240 degrees is negative 0.5. And if we were to draw in these angles, on the unit circle, they would look something like 60 is about here, 120 is about here, and 240 is about here. And what we talked about in the previous video is that all of these share that reference angle of 60 degrees to the nearest x-axis. So let's break down what that means and why having the same reference angle is giving them the same sine and cosine values, but sometimes trading up the positive and negative signs. So if we looked at just sine 60 degrees, we know that sine of 60 is 0.866 and cosine of 60 is 0.5. What are the coordinates of this red point on the unit circle where the terminal ray of 60 degrees is hitting the unit circle? And we know that the unit circle, when we did our math with the unit circle, we discovered that the sine of a degree is equal to its y coordinate on the unit circle, and the cosine of any given degree is going to be equal to its x coordinate of that point on the unit circle. So we have an xy coordinate of 0.5 comma 0.866. That is that red point on the unit circle. And if we were going to treat this like triangle trig, we would draw down and create that right triangle, and it would have an x side length of 0.5, and this y side's length would be 0.866. And remember, with our unit circle, the hypotenuse is always 1 because the radius of the circle is 1. So then let's think about 120 degrees on this unit circle. Again, we have this angle that has a reference angle of 60 degrees. This should really be a point right on the unit circle is what I'm going for here. Is that clear enough? Can you guys tell what I'm trying to draw there? Need a smaller pen is what I need. Okay, close enough though. Nope. Good enough. You guys can tell what I mean, right? So we have this right triangle around the reference angle 60 degrees. And so it's the same triangle, right? It's a triangle with an angle of 60 degrees and a hypotenuse of 1, which means that the side lengths must be the same. It must still be 0.5 and 0.866. But now we are in the second quadrant of our graph. And over in this area here, the y values are positive. So sine of 120 degrees gave us positive 8.866. But the x values in this quadrant are negative. If we go along the x-axis on this side, we're looking at negative x's. And that is why the cosine of 120 degrees is equal not to positive 0.5, but to negative 0.5 is because it's the same triangle here, but the x-coordinate at this point is going to be negative. We've got an x-coordinate of negative 0.5 and a y-coordinate of positive 0.866. Wow, apologies for my handwriting today, guys. So, quick review of the quadrants of a graph. We go counterclockwise around, starting over here is quadrant 1, where x and y are both positive, and then in quadrant 2, the x values are negative, but the y values are positive. In quadrant 3, the x and the y values are negative, and in quadrant 4, the x values are positive, the y values are negative. So let's think about any given angle on this unit circle. If cosine is equal to x, and then sine is equal to y, and tangent, we said, was y over x, then if we are in quadrant 1, are the x values positive or negative? They're positive, so cosine is going to be positive. In quadrant 1, sine is positive, or y is positive, so sine will be positive. And then tangent is y over x. A positive divided by a positive gives you a positive, so tangent will also be positive in quadrant 1. In quadrant 2, though, sine is y, so sine is still positive in quadrant 2. But the x values in quadrant 2 are negative. So that means that in quadrant 2, cosine is negative. So any angle between 90 degrees and 180 degrees will have a negative cosine and a positive sine. And then if cosine is negative and sine is positive, what do you think tangent will be, negative or positive? It's going to be negative because tangent is y divided by x, which means that it is going to be a positive divided by a negative number, and a positive divided by a negative gives you negative. So then in quadrant 3, looking at all the angles from 180 to 270, if we're in this quadrant with one of those angles, cosine is the x value, so it's going to be negative. Sine is the y value, it's also going to be negative. Tangent, therefore, is a negative divided by a negative, which gives you a positive. So in quadrant 3, tangent is positive, cosine and sine are both negative. That means any angle between 180 and 270, will have a negative cosine, a negative sine, and a positive tangent. And then in our last quadrant, quadrant 4, cosine is back to being positive. Sine is still negative, which means that tangent is a negative divided by a positive. So tangent is negative. We can always figure out this again because all we did was list whether x and y were positive or negative in each quadrant. But as a shortcut way of remembering this, we say all students take classes going around the quadrants, and we're looking at the starting letters of those 4 words, and that tells you what is positive in that quadrant. So in quadrant 1, all trig ratios are positive numbers. In quadrant 2, sine is positive, but cosine and tangent are negative. In quadrant 3, tangent is positive, but sine and cosine are negative. And in quadrant 4, cosine is positive, but sine and tangent are negative. So your shortcut to remember that is all students take classes. Quick note, what does this mean for the sign of cosecant, secant, and cotangent? Remember, those are our 3 reciprocal trig ratios. Sine is opposite over hypotenuse, but cosecant is hypotenuse over opposite. Tangent is opposite over adjacent. Cotangent is adjacent over opposite. And cosine is adjacent over hypotenuse. Secant is hypotenuse over adjacent. They will always match the sign of their reciprocal, When you flip a fraction upside down, it doesn't change the sign at all. So if sign is positive, cosecant is positive. If sign is negative, cosecant is negative. If secant is positive, or sorry, if cosine is positive, then secant is positive. If cosecant is negative, then secant is negative, and so on. So what can we do with this? Well, it helps us to figure out quickly what the sign is in positive or negative of any trig ratio is. So what is the sign of secant 135? Well, first of all, what quadrant does 135 fall in? It's between 90 and 180, 135. So that means that it's falling into quadrant 2. And secant is the opposite of cosine, or the reciprocal of cosine, excuse me. So I'm going to look in quadrant 2 and see that cosine is negative. Therefore, secant must also be negative. So I know that the secant of 135 is negative. And then a way that we've seen this sometimes on the region is we've seen questions like if the tangent of theta is greater than 0 and cosecant of theta is less than 0, in what quadrant does the terminal side of the angle lie? So let's just do this as a process of elimination. We have 4 possible quadrants. We know it's all students take classes, and let's check. We're told that tangent theta is greater than 0. Now, greater than 0 means that tangent is positive. So we can get rid of any quadrants where tangent is negative because we know the tangent value of this angle is positive. So in quadrant 1, tangent is positive because all trig ratios are positive. In quadrant 2, sine is positive, but all other trig ratios are negative, so quadrant 2 is out. In quadrant 3, tangent is positive, that one's good. In quadrant 4, cosine is positive, but sine and tangent are negative, quadrant 4 is out. Okay, we've eliminated 2 quadrants. We know it's either got to be quadrant 1 or quadrant 3. And then we're told that cosecant of theta is less than 0. So the cosecant is negative. And the reciprocal of cosecant is sine. So I know my sine is negative for this angle. So if we go into quadrant 1, in quadrant 1, all trig functions are positive. So cosecant is not negative. So that one's out. But in quadrant 3, tangent is positive, sine and cosine are negative, which means that their reciprocals are also negative. So we know that our angle, whatever it is, must be in quadrant 3. That's our answer. So quick check-in. If cotangent of an angle x is greater than 0 and the secant of angle x is less than 0, in what quadrant must angle x lie? Okay, so if cotangent is greater than 0, it's positive, and if cotangent is positive, then its reciprocal tangent is also positive. So in quadrant 1, everything's positive, so that checks out. In quadrant 2, sine is positive, but cotangent is negative, can't be quadrant 2. In quadrant 3, tangent is positive, check. In quadrant 4, cosine is positive, but tangent is negative, cannot be quadrant 2. Then we know that secant is less than 0, so secant is negative. And if secant is negative, then its reciprocal, cosine, is also negative. So let's check this out. If secant is negative, then let's see, in quadrant 1, everything is positive. Can't be out quadrant 1. We're left with quadrant 3 as the place where cotangent is positive and secant is negative. So our answer once again was quadrant 3. Okay, guys, you have some delta math. You're going to practice all of this with the unit circle and the positive and negative signs of trig ratios. Have fun. This is your last video of this week. So last week we did 4 videos, but we were hearing that you guys were feeling pretty overwhelmed. So this week we've only done 3 videos, and you get sort of some extra catch-up time. Email if you have any questions, and definitely try to stop into office hours, which we are having Monday afternoons from 2 to 4 and Wednesday mornings from 8 a.m. to 10 a.m. I hope I'll get to see some of you in office hours, and have a wonderful rest of your week. Bye.